We've looked at a lot of different technologies, so let's talk about putting them all together to solve actual problems in the real world. Now, if you've come here looking for a cheat sheet or a recipe or a specific process to follow for deciding how to design complex distributed architectures, well, that doesn't exist. I mean, that's why people who do this make the big bucks. But I can give you some ways of approaching the problem that might help, and a couple of examples that might prove useful as a guiding place to start when you're looking at similar problems. So let's do it. So, as you may know, I used to work at Amazon.com for about 9 years, and one of their main secrets to success, and it's not really a secret, I mean, this has been published in the New York Times even, is working backwards. So the idea is to always approach problems from the standpoint of your end user, your customer, and work backwards to figure out how to fulfill what that customer needs. Now, this is useful in all sorts of things, product design, and even in designing technical solutions. And as you'll see, as we go through a couple of examples here, the process of working backwards can be quite useful in actually designing the system that best meets the actual requirements of what the end user requires. So it's very tempting to always work forwards and start from the technology that you want to use, your preconceived notions of what systems might meet the needs of what you're trying to do. But often when you work backwards from what the end result needs to be, you end up with a very different solution, and often one that is better tailored for what you actually need to do. So there are some things you need to consider when you're thinking about the needs of your customers. It's not always a straightforward thing to articulate. First of all, what sort of access patterns do you anticipate from your end users? So are we looking at analytical queries that span really large date ranges that don't really need to come back instantaneously? Or are we talking about people that are hitting a website, a big website, potentially, where you get a huge amount of very small transactions for very specific queries that need to come back very quickly? That question alone will make a big difference as to what sort of technology you throw at the problem. What sort of availability requirements do you have? Do you live in an environment where if your system is down, it will bring down a huge website that brings in, thousands of dollars per second? If so, then availability is a big deal. Is it a stock trading system? In that case, you might also demand consistency. You might care even more about the fact that transactions don't get lost and they're always processed exactly in the correct order. So these are all questions to ask yourself when you're determining what the end user actually needs. More requirements to think about: just how big is the data you're talking about? So are we talking about data that continually grows forever over time? If so, then the things we're talking about with clusters and distributed computing probably make sense. But if it's just a small amount of data, maybe little lookups of, movie IDs to movie names, for example, you don't necessarily need a cluster to store that kind of data. So it might inform your decisions about how to store this data and replicate it. Maybe you can get away with something simpler. And that's another guiding principle too. Always go with the simplest solution that meets your needs. Simplicity is always going to be a good thing in the long run. Also think about how much internal infrastructure and expertise do you have available. If you have some internal knowledge about a specific system and you have already systems in place that realize it, then why not make use of them if you can? So, you'll always want to lean toward systems that are better understood and already deployed in your system that will make getting up and running on it much simpler. So sometimes you have to make trade-offs there. The ideal solution might be different from the solution that's sitting in front of you ready to go. And if the trade-offs that you have to make in going with what's available aren't too bad, then sometimes it makes sense to push forward with what you got in place already. Think about data retention policies too. This can trip people up a lot. So if this is based on some sort of consumer behavior or something, do you need to keep that data around forever for auditing purposes? Often in the financial world, that's a requirement. You need to keep that data around indefinitely, or at least, for some period of years during which you might be audited. But sometimes the opposite is true. If you're dealing with just customer behavior data on a website, you might find it advantageous to actually purge that data frequently, just for privacy reasons. If you have some state agency wants you to hand over records of some customer and you don't have that data to begin with, then that saves you a lot of work, for example. So sometimes there are corporate policies surrounding this sort of a thing that you should educate yourself on. Also think deeply about security requirements. You'll definitely want to get a security review and check with your legal department at your company as appropriate to make sure you are in compliance with any security regulations that may exist in the countries that your system will be operating within. And often they are more complicated than you might think. Think about latency as well. How quickly do your end users need to get a response? So, if this is something where you have end users hitting a website and that web page needs to render really quickly, then you probably only have milliseconds to get an answer back to the end user. So you're going to want to front your data with something like HBase or Cassandra or some very fast distributed database to actually vend that data to your web servers at the end of the day. Timeliness. Can your queries be based on day-old data, minute-old data? Think about how quickly your data needs to get processed. If you're just dealing with stuff that needs to be processed on a batch basis, daily or something, then an Oozie scheduled daily job and using things like Hive and Pig and Spark may be perfectly fine. Just output the results to HBase or Cassandra or MongoDB or something if you need to vend that at scale at the end. But if it does need to be near real time, where the behavior that somebody does this second will affect what they get back the next second, well, then you're looking at things like Spark Streaming or Storm or Flink, maybe combined with Kafka or Flume to actually get that data where it needs to be quickly. Also, future-proofing is often the work of the devil, as they say. You don't want to over-engineer things, but you do have to think about it. When you're talking about big data, it becomes very painful to move that data from one repository to another over time. So you do want to think at least a little bit into the future. It's hard to predict what's going to happen within a year or two, but if you do know things like, well, business analysts will probably want this data, or maybe I'm not going to have this business relationship with this particular cloud vendor in the long term, just give it some thought. You do need to think about mostly where you're storing this data in the long run, because that is a difficult decision to reverse later on. Cheat to win, and I don't mean cheating in an unethical manner, but if you have existing components that you can reuse, like we talked about, think about using them. You have to think about the business value of actually getting a return on investment of all the development work you're going to put into this system. And if by making a small compromise on, some small requirement that isn't that important to people allows you to shave off months of development time and maybe, thousands or even millions of dollars worth of hardware, that's great. You should think about doing that, right? And something that we also said a lot at Amazon was rebuilding existing technology, re-engineering things almost always has negative business value. These sorts of efforts end up taking a lot longer than you expect. They're much more expensive than you expect. And if you try to quantify the benefits of reinventing the wheel, it very, very rarely pays off. So also, keep it simple. What is the least amount of infrastructure you need to build? If you can import existing data with Scoop from an existing repository, do so. Don't rebuild an entire system for streaming in raw logs and processing them if you have the data already in the form you need somewhere else. So again, just look for shortcuts and take them whenever you can. And, sometimes some project manager or some manager may say, these are the requirements of the system I want you to build. Well, use your common sense. If you're looking at this and you say, well, if you could tolerate, something that has a little bit less consistency than that, I could save you a lot of time and money, at least mention it. You might be surprised at the answer, and they'll appreciate your forthcoming nature.